Today's topic is jet transforms. Jet transforms is used to convert discrete time domain into discrete frequency domain. It has many applications in mathematics and signal processing. For example, to analyze JPEG images, MP3 and MP4 songs, zip files, etc. we can make use of jet transforms. Jet transforms are mainly used to solve the difference equations. Coming to the definition here, jet transform of a sequence f of n for discrete values of n equal to 1, 2, 3 and so on, we define z of f of n equal to sigma n equal to 0 to infinity f of n into z power minus n, and the resultant is function of z, that is f of z here. Whereas sigma n equal to 0 to infinity f of n into z power minus n, which is called as one-sided jet transform. If sigma starts from 0 to infinity. Whereas sigma from n starts from minus infinity to infinity, the jet transform definition, sigma n equal to minus infinity to infinity f of n into z power minus n, which is called as two-sided jet transform. Okay. Now we will see some jet transform for the standard functions. For example, if f of n is 1, then the jet transform of 1 is, by definition, we can write z of f of n equal to sigma n equal to 0 to infinity f of n, that is defined as 1 here, into z power minus n. On expanding this, for n equal to 0, z power 0, that is 1, plus n equal to 1, z power minus 1, that is 1 by z, plus z equal to n equal to 2, 1 by z square, plus and so on. So it is the expansion like 1 plus x square plus and so on, that is 1 minus x. We have 1 by z as x in place of x to the power of minus 1. This gives z minus 1 by z to the power of minus 1 equal to z by z minus 1. So therefore, jet transform of 1 is z by z minus 1. This is one of the standard formula here. Now, let us suppose f of n equal to a power n, another sequence a power n, then jet transform of a power n, which is equal to, by definition, we have sigma n equal to 0 to infinity f of n. Here f of n is defined as a power n into z power minus n. And we write this as sigma n equal to 0 to infinity a by z to the power of n. Now we substitute n equal to 0, 1, 2, 3 and so on. We expand the summation here. For n equal to 0, we have 1 plus, for n equal to 1, a by z, plus for n equal to 2, a by z whole square, plus and so on. This is also same as 1 plus x square plus and so on, that is 1 minus x, that is a by z to the power of minus 1, which is equal to z minus a by z to the power of minus 1, or we can write this as z by z minus a. So this is the jet transform of a power n. Therefore, jet transform of a power n gives z by z minus a. And we know that jet transform of a power n, that is z by z minus a. Now, z transform of minus 1 whole to the power of n. So in place of a we have minus 1. This gives z by z plus 1. So we make use of a power n formula here to find out the jet transform of minus 1 whole to the power of n. And next one, let f of n equal to n, then z transform of n. So same by definition, sigma n equal to 0 to infinity, f of n is defined as n here into z power minus n. And expanding summation, n equal to 0 we have 0, n equal to 1, 1 by z, n equal to 2, 2 by z square, n equal to 3, 3 by z cube, plus and so on. And now by taking 1 by z as common here, then we have 1 plus 2 by z plus 3 by z square plus and so on. So this is the expansion of type 1 plus 2x plus 3x square plus and so on, which is equal to 1 minus x to the power of minus 2. Here we have 1 by z in place of x, that is 1 minus 1 by z to the power of minus 2. This gives 1 by z into z minus 1 by z to the power of minus 2, or we can write this as z square by z minus 1 whole square. Here z and z gets cancelled, so it gives z transform of n equal to z by z minus 1 whole square. This is another standard formula of a z transformation. To find out the z transform of n square, z transform of n cube, we make use of recurrence formula here for n power p, where p is the positive integers. And by recurrence formula, we have z transform of z of n formula. We have z of n equal to z by z minus 1 whole square. Okay. Now the recurrence formula for z power n power p is minus z into d by dz of z power d by dz of z transform of n power p minus 1. Now we need to find out z transform of n square, that is for p n p equal to 2. So we can write minus z d by dz of z transform of n. P is 2, 2 minus 1 is 1, that is z transform of n. So this is the recurrence formula here. Z transform of n power p is minus z into d by dz of z transform of n power p minus 1. We make use of recurrence formula. We substitute p equal to 2 here. We get z of n square equal to like this. And this is equal to minus z into d by dz of, we know that z transform of n, that is z by z minus 1 whole square. Now this is equal to minus z into, by using differentiation of u by v formula here, v u dash, that is z minus 1 whole square into v dash, z derivative is 1 minus u into v dash, v dash is 2 into z minus 1 by v square, that is z minus 1 whole power 4 here. By taking z minus 1 term as common, here we get minus z into z minus 1 minus 2z by z minus 1 whole cube. So that is equal to minus z into minus z minus 1 by z minus 1 whole cube. So which is equal to z into z plus 1 by z minus 1 whole cube. So the z transform of n square, that is z into z plus 1 by z minus 1 whole cube. Now we will find out z transformation of n cube. So that is p equal to 3. So by using recurrence formula, write this as minus z into d by dz of z transform of n power p minus 1, that is 3 minus 1. So this gives minus z into d by dz of z transform of n square. We know that the z transform of n square. So minus z into d by dz of z transform of n square is z square plus z by z minus 1 whole cube. Now again, by using differentiation of u by v formula here, we get minus z into v into, that is z minus 1 whole cube into u dash, that is 2z plus 1 minus u into v dash 3 into z minus 1 whole square by z minus 1 whole to the power of 6 equal to minus z into, by taking z minus 1 whole square as common, we get z minus 1 into 2z plus 1 minus 3 into 3z square plus 3z by z minus 1 whole to the power of 4. Z minus 1 whole square, z minus 1 whole square gets cancelled from both the numerator and denominator. So we get z minus 1 whole to the power of 4. And now this is equal to minus z into. On expanding this, 2z square minus 2z plus z minus 1 minus 3z square minus 3z by z minus 1 whole to the power of 4 equal to minus z into, and we have minus 3z square plus 2z square, that is a minus z square minus 2z plus z minus z again minus 3z, so minus 4z minus 1 by z minus 1 whole power 4. So this gives z transformation of n cube, that is z into z square plus 4z plus 1 by z minus 1 whole power 4. Okay. Now z transform of a unit step function. Unit step function, we know that the unit step sequence of f of n is defined as f of n equal to 0 for n is less than 0 and equal to 1 for n is greater than or equal to 0. Then we will see z transform of a unit step function here. By definition of z transform, z of f of n equal to sigma n equal to 0 to infinity f of n into z power minus n. Here for n equal to 0 and so on, f of n is defined as 1 into z power minus n. On expanding the summation, we have a 1 plus z plus 1 plus 1 by z plus 1 by z square plus and so on. That is z by z minus 1. So the unit step function step sequence of a z transformation gives z by z minus 1. Next, we will see the unit impulse function sequence. Unit impulse sequence of a z transform. Unit impulse sequence means if f of n equal to, so this is defined like this, 1 when n equal to 0 and 0 for other values that n is not equal to 0. Then z transform of f of n equal to sigma n equal to 0 to infinity f of n into z power minus n. So this gives for n equal to 0, on expanding the summation n equal to 0, f of n is defined as 1. For other values it is defined as 0. So we have 1 plus 0 plus 0 plus 0 plus and so on, that is equal to unity 1. Okay. Now we will see the properties of z transform. So main properties are linearity. We know that a linear property. So like z of a into f of n plus b into g of n, which gives a into z transformation of f of n plus b into z transformation of g of n. Next, another important formula, property, change of scale property. So this is a very important one. If z of f of n equal to f of z, then z transformation of a power n into f of n gives f of z by a. Or z transformation of a power minus n f of n gives f of az. This is called as change of scale property or damping rule. Now by using, we make use of change of scale property. We solve some problems here. So we find out the z transform of a power n into n by using change of scale property. And we know that the z transformation of n, z transformation of n is z by z minus 1 whole square. And let us suppose this is equal to f of z. By change of scale property, we have z transformation of a power n into f of n is same as f of z by a. So therefore, z transformation of a power n into f of n is defined as n here equal to f of z by a. That is, we replace z with z by a. Then we have z by a by z by a minus 1 whole square, which is equal to z by a by z minus a whole square by a square. That is a by az by z minus a whole square. So we find out z transformation of a power n into n by using change of scale property like this. And we will find out another one, z transformation of a power n into n square, same by using change of scale property. For this we need to find out z transformation of n square first. And we know that the z transformation of n square is z square minus z by z minus 1 whole cube. Okay? And let us suppose this is equal to f of z. Now by using change of scale property, that is z transformation of, so z transformation of n square is z square plus z by z minus 1 whole cube. We consider it as f of z. Now z transformation of a power n into n square, which is equal to f of z by a by using change of scale property. So that means we replace z with z by a in f of z. Then we have z by a whole square plus z by a by z by a minus 1 whole cube. So now this is equal to z square plus az by z minus a whole cube by a. Or we can write this as a into z square plus az by z minus a whole cube. So that is z transformation of a power n into n square gives az into z plus a by z minus a whole cube. So by taking az as common, we get az into z plus 1 by z minus a whole cube. This is z transformation of a power n into n square. Okay. Now another example, z transformation of 1 by 2 whole power n plus 1 by 3 whole power n. We will find out the z transformation for this sequence. By definition of z transform, we have z of f of n, that is 1 by 2 whole power n plus 1 by 3 whole power n. So we write this as sigma n equal to 0 to infinity f of n, that is 1 by 2 power n plus 1 by 3 power n into z power minus n. By linear property, we can write this as sigma n equal to 0 to infinity 1 by 2 power n into z power minus n plus sigma n equal to 0 to infinity 1 by 3 power n into z power minus n. On expanding the summation, for n equal to 0, we have 1, for n equal to 2, 1, so for n equal to 1, we have 2z, n equal to 2. See, here for n equal to 1, 1 by 2z, n equal to 2, 1 by 2z whole square. For n equal to 3 and so on. Plus, on expanding this summation, second one, for n equal to 0, we have 1. For n equal to 1, 1 by 3z. For n equal to 2, 1 by 3z whole square. Plus, and so on. Plus, and so on here, remaining terms for n equal to 3 to infinity. So this is same as 1 plus x square plus and so on. That gives 1 minus x. X is 1 by 2z here to the power of minus 1. Plus the second one is also same as 1 plus x square plus and so on. That is also 1 minus x. X is 1 by 3z here to the power of minus 1 equal to. This is 2z by 2z minus 1 plus this is 3z by 3z minus 1. By solving this, we get 12z square minus 5z by 6z square minus 5z plus 1. So this is z transformation of 1 by 2 power n plus 1 by 3 power n. Yeah, next we will find out the z transformation for f of n equal to 1 by n. That is z of 1 by n. By definition, z of 1 by n is sigma n equal to 0 to infinity f of n, that is 1 by n into z power minus n equal to. Here the summation starts from n equal to 0 to infinity. For suppose we substitute n equal to 0, 1 by n, it is not defined. So we rewrite the summation as sigma n equal to 1 to infinity. We start n from 1 to infinity because of n equal to 0, it is not defined. The given function is not defined. So we define it from n equal to 1 to infinity, 1 by n into z power minus n. Or we can write this as n equal to 1 to infinity, 1 by n into 1 by z to the power of n equal to, and expanding the summation now, we have n equal to 1, we get 1 by z, n equal to 2, 1 by z whole square by 2, for n equal to 3, 1 by z whole cube by 3 plus and so on. And this is same as x plus x square by 2 plus x cube by 3 plus and so on equal to minus log of 1 minus x. The expansion of x plus x square by 2 plus x cube by 3 plus and so on gives minus log of 1 minus x. So now by making use of that formula, we write here minus log of 1 minus x. X is 1 by z here. So now this is equal to minus log of z minus 1 by z. Or we can write this as log of z by z minus 1. So therefore, z transformation of 1 by n is log of z by z minus 1. Okay.